So once sedimentary rocks are formed, they can be brought up to the surface by erosion of material on top. And once they're exposed at the surface, these two will be prone to the processes of weathering and erosion. This is why we call it Earth's natural recycling system. It really does just feed into itself. So there are a few different types of weathering that we can discuss, and these are chemical and physical weathering. Chemical weathering will change the chemical composition of a rock, whereas physical weathering just breaks down the rock into smaller and smaller pieces. So once a rock has undergone weathering, it can then get eroded away. So you can think of weathering as the breakdown of rock and erosion as the removal of these pieces of material. Once these pieces of material are eroded away, we call them in transport. And transport can happen through water, wind, and even at the base of glaciers. It's essentially any medium that will take sediment from one location and move it to another, where it will eventually be deposited. Now, the size of sediment that can get transported is dependent on the energy of a flow. If you consider a slow-moving river, it can only pick up little pieces of clay, as it's quite lethargic. Think about when you're really weak and lethargic getting out of bed. Do you have the energy to pick up big dumbbells like Arnold Schwarzenegger, or maybe just a little baby dumbbell? It's the same thing. So when we're talking about big, fast-moving rivers, they can move boulders sometimes, and glaciers, they've got immense amount of power behind the ice, so they can move huge stones. So when you consider a sedimentary rock, if it's very coarse-grained, it was deposited by a fast-moving flow, whereas very fine-grained sedimentary rocks are more slow-moving flows. And this is important when geologists are reading the rocks in terms of building a depositional environment from which these sediments were deposited in. Sorting is a term that geologists use to describe if a sediment sample contains sediment all roughly the same size, well sorted, or if it has sediment with different sizes in it, poorly sorted. Generally speaking, sediment that has been transported a long way will be very well sorted, and sediment that has been transported only a short distance will have poor sorting. Think about when you clean your room. Given enough time, you can turn your room into a well-sorted area. If you do it in a rush, it's poorly sorted. As you can see from the animation, when a sample is poorly sorted, it contains sediment that are quite different in size, whereas well-sorted samples contain sediment that are all roughly the same size. The higher degree of roundness of sediment, the longer it has been in transport, is a general rule. Let's have a look at the demonstration of sugar cubes. The longer these sugar cubes are rattled around in their shaker, the rounder the edges will become. This same process occurs in the wild with sediment. The longer they are transported and battered by other sediment also in transport, the rounder the edges will become. So in summary, sorting, size, and roundness are all important clues that geologists use to unlock the past. So with this, I implore you to go for yet another walk, find some sedimentary rocks, and make some inferences of your own about how they were formed. Enjoy.